So now let's talk about average value, which will mean if we find these total values that are over this interval from A to B, we can also find what's happening on average per unit if, when we take our definite integral from A to B, what we want to do is multiply by 1 over B minus A. So what that's doing is it's taking the distance of the interval, and it's basically we find that total area under the curve, and we're dividing it by the length of the interval. So that's dividing it up in terms of the per unit base that we want to use. So if we let f be a continuous function from A to B, and we want to find its average value from A to B, that'll be given by, and we can use the notation y with a subscript of av, so that just means the average of y equals 1 over b minus a times the definite integral from A to B of our function f of x. So let's take a look at a few examples with this, as well as a business application too. So find the average value over the given interval. So we have our function 16 minus x squared, and we're looking from -4 to +4. So what we'll do with this one is we're going to find our average value. It'll be 1 over, and what we'll do is we'll have a is -4, b is +4. So we're taking 4 minus -4, so it's a 4 plus 4, and the definite integral -4 to 4 of 16 minus x squared dx. So we're taking 1/8 times the antiderivative of 16 minus x squared, so 16x minus x cubed over 3, from -4 to +4. And we'll just start simplifying. So we'll have 1/8 times, we'll plug in +4, so 16 times 4 minus 4 cubed over 3, minus, and then we'll plug in -4, so 16 times -4 minus -4 cubed over 3. And let's just go ahead and put all of that into the calculator. So just gonna copy it in. So we're gonna have this 1/8 on the outside, and then inside the parentheses we're gonna have 16 times 4 minus 4 cubed over 3. Close those parentheses, then minus, still in the parentheses multiplying with an 8, so you have 16 times -4 minus -4 cubed, -4 in parentheses cubed over 3. And we're getting a 10.67 or a 10 2/3. We could write that a few different ways. Let's go 10 2/3. 10.67. You can just round to a decimal. So the average value over the given interval is 10.67. So what this means is that there's this area under the curve from -4 to +4. So if we take a look at the graph, we have our parabola opening downwards, and you can see like it's going to a height of 16 there. So if you think back to our Riemann sums, looks like we'd have an area of 16 being added in there. So we have a large area here from -4 to +4. So while we have this total area, which would actually be 8 times the answer that we just found, that would give us the total area under the curve. What we did is we divided it up so that if we're looking at an interval of 1, on average, what's the area under the curve per unit? So if we think of those rectangles kind of again, but we're fitting under a curve here, on average, it's at 10.67, which if you see our height there of 10, that kind of makes sense for an average of these different heights because they're kind of lower, but then we get all these really high values, and it'll just average out to 10 2/3. So it's the difference of looking over the total interval and describing the total area versus on average, what are we seeing per unit as the area under the curve. So on average, we're seeing 10.67 square units per unit. Okay, let's take a look at some applications. So during a 9-hour workday, the production rate at time t hours after the start of the shift was given by the function r of t equals 5 plus square root of t cars per hour. So they're producing 5 plus square root of t cars per hour, given the amount of time that's passed, and we want to find the average hourly rate of production. So what we want to do is we want to evaluate this from the start of the workday, so when t equals 0 to t equals 9. So over 9 hours, on average, how many cars are they producing? So this r of t is telling us the total number of cars. So like if we looked at r of 9, that would tell us the total number of cars that were produced. That would be the production for that hour. So what we want to do is we want our definite integral from 0 to 9. So we're getting this total number of cars produced, so 5 plus square root of t, or I'm going to write it as t to the 1/2 dt. So this definite integral 0 to 9 of that function, that would give us the total number of cars that were produced over the entire workday. But we want the average hourly production. So with that, that's where we make this an average. So we're looking at 1 minus, and then it would be 9 minus 0, multiplying with that definite integral. So we want to take that total production and then divide it up by the 9 hours of the workday. So we're going to have 1/9, and then the antiderivative of 5 plus t to the 1/2, so 5t plus t to the 3/2 over 3/2. So that'd be the same as 2t to the 3/2 over 3 from 0 to 9. And let's go ahead and plug in 9. 5 times 9 plus 2 times 9 to the 3/2 over 3. And then if we plug in 0, that's all just going to be 0. So with that, we can go to our calculator and plug it in. So let's see, a 1/9 on the outside, and then that's going to be multiplying with 5 times 9 plus 2 times 9 to the, and I'm going to use parentheses here for 3/2. And then that needs to be divided by 3. So 7. So on average, 7 cars are produced per hour. So what we would have is if we multiply that by 9, so like across the workday, 63 total cars would be produced. But on average, by dividing it by that 9 or multiplying it by the 1/9, that way we're seeing on average what's happening per hour. So this last one is a business application. So we're looking at a solar panel manufacturer. We have our marginal revenue is r prime of t equals 75 e to the t minus 2t. And we have the information that r of 0 is equal to 0, where r of t is the total accumulation revenue in dollars after t days. The company's marginal cost, c prime of t, is given by 75 minus 3t, and we have that c of 0 equals 0. So we have a coordinate there to work with, where c of t is the total accumulated cost in dollars after t days. So, a few different ways we can go about this. But what we want to end up with, since we're evaluating the total profit from t equals 0 to t equals 10, what we're going to need is a profit function. So profit is calculated by taking revenue minus cost. So with that, we need our revenue and cost function, so we're going to need to use some antiderivatives here. So what we want to eventually do is, so if r of t is the accumulated revenue and c of t is the accumulated cost, then P of t is going to be the accumulated profit. So what we can do is just find P of 10. So that'll be the accumulated profit between 0 and 10. So with that, we need to take R of 10 minus C of 10. So finding our revenue function, we know R prime of t is equal to 75 e to the t minus 2t. And what we need to do is take the antiderivative. So taking the antiderivative to get r of t. Let's see, the antiderivative of 75 e to the t, we are going to just still have 75 e to the t. Antiderivative of negative 2t, so that'll be a negative 2t squared over 2, so negative t squared. And then because this is indefinite, we're going to have a plus c at the end. And that's where this value r of 0 equals 0 is going to come in, is that revenue should be 0 when t is equal to 0. So what we'll have is 75 times e to the 0, which is just 75. And then minus 0 plus c. So c is going to equal negative 75. So our revenue function is 75 e to the t minus t squared minus 75. And now we'll do the same thing with the cost function. So c prime of t is 75 minus 3t. And we want to find c of t. So to do that, we need to take the antiderivative. So antiderivative of 75 is going to be 75t. Antiderivative of negative 3t is going to be a negative 3t squared over 2. And we'll have a plus c. And it's that cost is 0 when t is 0. So if I plug in the zeros, what we're going to get is c equals 0. So cost function is 75t minus 3/2 t squared. Okay, so now that I have that, we can find p of 10 by plugging in 10 to our revenue function. So we're going to have 75 e to the 10th power minus 10 squared minus 75. And then we're going to subtract the cost function, so 75 times 10 minus 3/2 times 10 squared. So let's go ahead and plug that in. It's going to be a big old number of 1651209.94. Let's see. So $1,651,209.94. So that's our accumulated profit over the 10 days. So now, if I want that average daily profit, and it's like I want to multiply by that 1 over 10 minus 0. Really what we're doing is we're just taking that number and dividing it by 10. If we want the per day average, we would just take that accumulated profit and divide it up. So what that should be is $165,120.99. Sorry, I got kind of lost writing the numbers. $165,120.99. That's how we would say it. And that would be per day for the first 10 days on average. So with that one, using antiderivatives and profit, revenue, costs together, and with that we can find our average daily profit.